So this example is not a problem so much. So let's just read it together. On the Kelvin scale, absolute zero is the temperature 0 Kelvin. Although temperatures very close to 0 Kelvin have been produced in laboratories, absolute zero has never been attained. In fact, evidence suggests that absolute zero cannot be attained. How did scientists determine that 0 Kelvin is the lower limit of the temperature of matter? What is the absolute zero on the Celsius scale? Okay, well, so the absolute zero on the Celsius scale, we sort of know that. That's like negative 273 something, right? Or ish. I don't know. Well, let's see. This is more of a story. So, the determination of absolute zero stems from the work of the French physicist Jacques Charles. Charles discovered that the volume of gas at a constant pressure increases linearly with the temperature of gas. You may remember Charles' law in chemistry. I believe that's a thing. The table illustrates this relationship between volume and temperature. To generate the values in the table, 1 mole of hydrogen is held at a constant pressure of 1 atmosphere. The volume V is approximated and is measured in liters, and the temperature T is measured in degrees Celsius. Okay, so let's rethink everything that happens. So look how the temperature is getting hotter as you go to the right, and the volume is getting larger. And they're suggesting that it happens linearly. So let's see, from negative 20 to 0, so when it goes up by 20, it goes up by about 2. And you see that the next time when it goes up by 20, it goes by about 2 again. And that seems to be consistent. Okay, that's fair. So the points represented by the table are shown in figure 1.33. Oh, they give us a graph. Cool, very nice. Moreover, by using the points on the table, you can determine that t and v are related by the linear equation. So if we know they're linear, which is what Chuck told us, then we can use these points to write the equation. So we get that v equals that, and then they solve for t. Yeah, they solve for t. And so this makes sense. So they say by reasoning that the volume of the gas can approach zero, but never equal or go below zero, you can determine that the least possible temperature. Because you think that's another thing with gas. I guess they're not talking about it here, but when gas gets cold, it compresses. So that's what they're saying is that when they compress it to the least possible volume, that's going to be the coldest that it can be. So by reasoning that the volume of the gas can approach zero, but can never equal or go below zero, you can determine that the least possible temperature is given by the limit as V approaches zero. And see, in reality, we only care about it from the right because we're going down to zero. We're not going up to zero from the negatives. But all the same, we just plug in zero for the volume. You get the negative 22 over 0.08, and that's the negative 273, roughly. That is zero on the Celsius scale. Because how they decide what zero is on the Kelvin scale, I mean, they just made it up. They just called it zero. There's just like no energy. That's zero. But they had to convert that to the Celsius scale. And so that's what it is. And that's why when you convert from Celsius to Kelvin, you just subtract 273.15 if you want to be specific. And so that's just a good story. You can see these bros. What do? They did this work. That's the study that we just did. Was based on them. They got a lot of sig figs. Good for them. So yeah, that's just a quick little application of a limit to calculate something that's pretty important.